Hello everybody. Welcome back to In the Loop. This is a podcast by Texas Guadalupe. We are the University of Texas Hyperloop team, and I am your co-host, Gavin Nader. I am the head of business, and I'm a senior studying economics. And today we have a guest host.
Hi, my name is Uriel Buitrago. I was the frame lead for Texas Guadalupe last year, and I'm currently pursuing my master's in computer science.
So today we are joined by Gary Bond. Mr. Bond worked for Boeing for 26 years, becoming a technical fellow there, and then joining Solvay as a technical fellow in 2020. Gary is a composite specialist, a U.S. Air Force veteran, and an entrepreneur. And in his free time, you can find Gary up in the sky in his Grumman AA-5B Tiger. Welcome to the show, Gary.
Thanks. Glad to be here.
So yeah, every time I log into LinkedIn, I get very jealous because I see these epic pictures and videos of you flying. I actually have a couple of videos here. So I guess to start, I think I saw on LinkedIn that you hadn't flown in 17 years.
Yeah.
What made you want to come back, and how did it feel to get back in that seat?
Felt incredible. It was great. Yeah, I never really wanted to get away from it. It just that we started a family, and that was my priority. And I just felt like I wasn't flying enough to be safe. So kind of grounded myself and helped raise my family. My kids are now 19 and 16, and I've got one off in college. So starting to get some more time opened up and just decided to jump back into it.
Okay, cool. Yeah, I used to follow a couple bush pilots on YouTube. And it's so cool how one of them lived on an airstrip. And they would just walk out of their front door, get in their plane, and fly to a restaurant 3 hours away. Have you ever done anything like a meetup or just fly to go get breakfast or something?
Oh, sure. Yeah. We do a lot of places have a breakfast on Saturday mornings, a lot of small airports in order to draw people in. And that's a lot of fun. You get together with a lot of people that are, have similar interests in aviation and get to see some kind of cool planes that you might not otherwise see. So that's always a blast. Yeah, I would love to live in a place where, my garage is my hangar. That would be awesome, but I don't know if that'll ever happen.
Yeah. So why this plane in particular?
So there were a lot of factors that went into purchasing the airplane. I was looking for something that was pretty reliable, low maintenance, low annual inspection costs, something that would have fairly low insurance costs. So that kind of directed me towards a single engine, fixed prop, fixed gear. But I wanted something that went a decent amount of speed and could carry a decent amount of load. So I wanted something that could, travel cross country and actually be a useful, both personal and professional instrument. So that kind of limited the target that was out there. And eventually I settled on the Grumman Tiger as being kind of the best mix of all the different things. It's not the fastest airplane out there. It doesn't carry the most load. But as far as the combination of all the attributes that I was looking for, it was definitely the best choice for me.
And then I think I saw that you said you've flown to visit your son in college. What is that process like as a private pilot to just get in a plane and go, I don't know, go fly somewhere?
Yeah. So, most of I'm only a VFR pilot. So visual flight rules. I haven't gotten my instrument rating yet. That's next on my list. So essentially I have to fly when the weather is decent. It has to have sufficient visibility. The cloud ceilings have to be a certain height. And then basically I just call up the tower at Huntsville. I can go to my plane at any time. Get my plane ready, call up the tower and tell them where I'm going, and they give me clearance and I take off, and that's basically it. There's very little bureaucracy about it. There's a great deal of freedom to be able to just pick up at any time and head out anytime that I want to go. I don't necessarily have to file a flight plan. I can kind of fly whatever route I want when I'm VFR, as long as I stay clear of particular airspace and weather. But it's a great freedom to be able to do that.
Wow. Yeah, that seems crazy. It's basically just getting in your car and flying somewhere.
Yeah, yeah, pretty much.
Do you have any big future trips planned that you're excited about?
Well, I'm going to be working on my instrument rating. And then I think that, maybe a big trip for me would be to go out back to Arizona where my parents live, where I grew up and go visit them. So that's probably a 2-day trip for me, an overnight stay probably somewhere. Probably could do it in one day, but it would be a long day and I might not be safe at the end of it. So I'll probably break it up into 2.
Okay, cool. Your plane will probably come up again. I just thought it was so cool. Look at this picture.
Yeah, and it's right now in pieces, which is kind of cool in itself. I'm doing its annual inspection, doing an owner assisted. So I'm not a A&P, an airframe and power plant mechanic, but I'm working with one. And to me, it's the best way to learn your plane is to actually tear it apart and understand how it's built from the ground up. So it's been a real learning experience for me, and I've really been enjoying it. Of course, I can't wait to put it back together and actually go fly again, but we'll get there.
So was it a kit?
Definitely.
No, it's not a kit plane. It's a certified plane. I feel like after this, I've put most of it back together almost like a kit. So
Yeah.
I actually I learned to fly based on helping my CFI, my certified flight instructor, put together a Lancer 4P, and that's a highly composite kit plane. And essentially, I traded my knowledge of composites for his knowledge of flight, and that's how I got my private pilot license.
Okay. And
Wow,
so did
that's
you get
awesome.
your private license recently, or was that a long time
Uh,
ago?
yeah, so I got my private pilot license back in, let's see, that would be 2000, 2001, something like that. Um, yeah, is when I got it. Your private pilot license basically never expires. You have a medical that you have that expires, and you have currency requirements. So you're required to have taken off and landed a minimum number of times within 90 days of flying, and there's things like that. So my private pilot license basically I still had during that entire 17 years when I wasn't flying, but I didn't have my medical, I didn't have my currency. I had to get checked out and kind of recertified to fly again.
Yeah, I guess I had to go through kind of a similar process, but definitely not as stringent as yours because I got my private pilot license for unmanned aircraft systems.
Oh, uh-huh.
So I'm technically allowed by the FAA to fly drones commercially
Oh,
because that's
cool.
something that I enjoy. Yeah, so but for me, I have to renew it every 2 years.
Okay, that's
Yeah,
very cool.
it's a lot of fun.
Okay. So going back sort of to your beginning of your career,
Hmm.
um, what was your time like in the Air Force, and then how did you end up at Boeing?
Yeah, so my time in the Air Force was really good for me personally. Now, professionally, it really didn't do much for me. I didn't do anything having to do with planes whatsoever. So, like 10% of the Air Force is somehow associated directly with planes, and 90% of the Air Force is supporting that 10%, right? So I was in the 90%. I was actually working in the dining hall of a hospital. So I basically had nothing to do with aviation whatsoever. But what it did do for me was teach me a lot about self-discipline. A lot of times, I think the limits that we put on ourselves are just that, limits that we put on ourselves, and they're not real limits. And I found that I was able to go further than I thought and be able to do more than I was able to before. So I do know that for sure. I had gone to college for a couple semesters before I joined the Air Force. And after I was in the Air Force and went back to college, I was a much better student. I was way more disciplined, much more focused, and just able to do a lot more. So I think from a personal standpoint, it was really good for me. And then I got out, went back to the University of Arizona in Tucson, finished up my degree there. Was looking around for jobs. Always wanted to be in aerospace and aviation, but at the time, this was 1994. The aerospace world was going through some pretty difficult times. There was a lot of
Mm.
defense drawdowns, end of the Cold War, things like that. So I didn't really think I was going to be able to get it into anywhere. I was planning on working on for Intel or AMD or something like that, because there's a lot of that in Arizona, and chip manufacturers. It was really hot at the time, looking for material scientists. And my background was not in composites. So I'm trained, I was trained as a ceramist or a metallurgist, surface science and things like that. So when I got a call from McDonnell Douglas in St. Louis to come out for an interview, I was like, yeah, that'd be great. I didn't think there was any way I was going to get the job, but they hired me. And so that's how I ended up going to St. Louis, working for McDonnell Douglas, 1994. And then in 1997, they merged with Boeing. And so it's been with Boeing ever since. So 26 years combined of McDonnell Douglas and Boeing.
So your sort of like dream job called you.
Yeah, right.
That's crazy.
Yeah. Pretty amazing.
Yeah.
Just such a great story. So you mentioned that you were in college, then you went to the Air Force and came back. Were you studying material science or engineering prior to the Air Force? No?
No. Yeah. So that's a good question, actually. My original major, after I left, when I graduated high school and went down to my first semester at the University of Arizona, was in fine arts photography. So it had absolutely nothing to do with engineering whatsoever or technology. I still love photography. I mean, that's one of the things, one of the reasons why I love to do the videos and things like that for my plane. But it was not something I could really see myself making a career out of. So, and at the time, I just wasn't sure what I wanted to do. And I figured, well, if nothing else, the Air Force will help give me some direction. So that's why I joined. And then while I was in the Air Force, I changed my major to English. So I was fine arts major. Then I went to English, which I still love to write and things like that. And that's actually a really useful skill for engineers. It's probably a weakness, I would say, in general of a lot of engineers, is being able to write well. But then after that, and actually after the Challenger tragedy in 1986, I decided that I wanted to do aerospace engineering. So I switched to aerospace engineering, and then eventually switched over to material science and engineering. So it's kind of a long, strange trip for me.
That's amazing. That's amazing. I guess I got into like drones for the same reason, like photography and just wanting to pick up a drone and take nice videos and pictures of beautiful landscapes. So I connect with you on that point.
Yep.
And it's definitely a great hobby to have, and something that, I think a lot more people should do.
Yeah, it's very cool. You get to see perspectives. You get to take, photos and videos from perspectives that most people just can't. So it opens up a whole world for you. That's really cool.
Definitely. So now that, once you went through that crazy college trip and in the Air Force, came back, graduated, and finally had your dream job, what were some of your biggest achievements and also challenges while serving in your 25 career at Boeing?
Well, there was a lot of stuff that I did, and a lot of things that we accomplished. There was also a lot of things that didn't get accomplished, and so that's one of the things I would probably stress, is that out of everything that I worked on over my entire career, I would say maybe 10 to 15% of them became really successful. So the vast majority of the stuff that you work on sometimes dies a quick death. Sometimes it's a slow and painful one, but just doesn't get anywhere, especially in research and development. And that's just the nature of the beast, Some of the stuff that I really enjoyed working on, and some of my best accomplishments, I can't even talk about. So, I mean, that was, we have that world too, that we live in, and they're just things that we can't talk about. But, I will say this, probably two of the things that were biggest in my career was a manufacturing development program in which we worked on building very large scale composites and working on some innovative assembly techniques.
Nice.
And the thing about that particular program was not so much the technology. I like the technology, and the technology was very interesting and very useful and has spread throughout Boeing. but it was really about the team. And I guess that's one of the things, if you guys follow me on LinkedIn with Laminate Life, I really try to stress is it's really about the people. And it truly is. The team that we had on that particular program was really focused on the goal and was really willing to do whatever was necessary to achieve that. Was really interested in working together, jumping in wherever there was a need, and just helping each other out to be able to achieve that. And that's always a great thing to be able to. It's not common, unfortunately. I wish it was. I wish every team that I ever worked on was like that, but it's not that way. A lot of times people have their own agendas, and they may be at differing agendas than what the overall program has, and people trying to build up their own empires, within companies and things like that. And it just, you tend to have a lot of different motivations in people, and people may get along okay, but it's not the same as everybody really working together and believing in the goal, which was the case in this one particular production manufacturing program. And the other thing that I would point to in my career was the development of the 5320-1 resin system. So that was a DARPA program that was won by a couple people at Boeing, Jim Thomas and Gil Hahn. And I actually took over as principal investigator on that program after they won it, primarily because Jim Thomas had moved to Italy. But so his loss or gain, depending on how you look at it. So we ran through that program. The Air Force basically was running that, helping with DARPA direction, and the idea was to develop an out of autoclave vacuum bag only composite material system that would be equivalent to the autoclave systems that were current at that state of the art at the time. And the thing that really made this program was really the partnership. And it was a true partnership between the material supplier, which was Cytec at the time, now Solvay, and Boeing. And the fact that we actually failed to begin with. We had a resin system that actually worked at a lab scale, but then when they scaled it up to production size, there were problems. And that's the reason why there's a -1 after 5320. It originally started at 5320, and they had to go to a -1. So like all great stories, right? You have difficulties and challenges that have to be overcome. And we did. And that was really a true team effort between Boeing and Solvay, working extremely closely together, Solvay listening to Boeing's needs, us listening to Solvay's, basically what's doable, what can be done, and kind of coming to a compromise of things that generated a material system that now has really kind of taken off and is used in a lot of different places and companies and applications. So it's just, when you strike out, 90% of the time, when you hit a home run, it feels really good. So that one was a home run. And that's one of the things that I feel good about in my career.
It's amazing. Such a great story. And I guess at Texas Guadalupe, we can relate on that point of looking for manufacturing methods that are out of autoclave. And I guess for our listeners that aren't very familiar with composite materials and manufacturing, if you could explain the importance and value of having a out of autoclave resin system.
Sure. Yeah. So typically composites are thermosetting composites, at least, are typically cured in an autoclave, which means that they're cured with heat and pressure. The autoclaves are extremely expensive. And if you can get rid of that so that you can cure it just in an oven, and the only pressure that you have on it is the vacuum bag itself, so 14-ish PSI, pushing down instead of needing 100 PSI, for instance, in an autoclave. It is a significant cost savings in capital costs. You don't have to buy the autoclave. An oven is much cheaper than an autoclave. And it opens up a whole supplier base of lower cost labor of suppliers who don't have the resources to have large autoclaves, but could purchase an oven. It also allows you to use, in this particular case, at least 5320-1, it can cure at temperatures as low as 200 degrees Fahrenheit, which allows you to use low cost tooling for prototyping. And then if you want to move to production, you can invest in your tools after the design is kind of stabilized. So it allows a lot of process flexibility. It allows lower initial costs up front, and reduces the overall costs in the life cycle.
Wow.
Definitely a more accessible, you made it more accessible for people to use composite materials. So that's a great achievement.
So sort of to like a more general question, what are the, like, what is composites good for and what are composites not good for?
Well, you know what? I actually like that second question better than the first question, because I don't know if you guys have seen my composite truisms, but the number one, the very first ply down is just because you can build something out of composites doesn't mean that you should, right?
Yep.
So composites are really good for in-plane loads. So if you have something that is loaded in an XY kind of plane with very little of Z direction kind of loads, composites are really good for that. So like skins of aircraft or you know, any kind of aerospace platform, skins are really good. Things like landing gear, where you have loads in almost any particular direction, is not really that good for composites, because composites typically are only good, well, mostly good in the direction of the fiber. So the fiber is what is really carrying the load, and the fiber is typically in plane, not out of plane. So composites are, you know, there's a lot of advantages to them. There's fatigue advantages. There's corrosion advantages. There's life cycle inspection advantages, things like that. But there's disadvantages to them too. They're definitely higher cost. Initial, the material, you know, system is probably somewhere in the $70 to $100 a pound versus $4 to $5 a pound for aluminum. So I mean, there's, you know, huge differences in the cost up front. On the other hand, composites are an additive process. It's not subtractive. So you're not going to take a big billet of composites and hog it out to the shape that you want, like you would with aluminum. So your buy to fly ratio is typically better. So you kind of have to think about that in looking at the overall cost of it as well. But there's definitely areas where composites shine, in areas where it's mostly planar loaded. And if there's fatigue limitations and things like that, and weight critical structure, I think composites definitely have a place, but they do not have a place everywhere, not yet. And I don't know that we'll ever get there. As a material scientist, I believe in choosing the right material for the right application.
Yeah, it's interesting because I've seen like new age space companies like Firefly and Rocket Lab. They're starting to use like, composite rockets. Anything like about that and why that might be?
Yeah, it's primarily for weight. It's really the main reason why. It's not really for fatigue, because it's in general it's not reusable. Maybe some of their stuff is reusable, but I would say primarily it's being driven by weight. So it's extremely expensive to put, you know, a pound of mass into orbit. And so every pound that you don't have to launch off the ground is maybe a pound more of payload that you can deliver. So any kind of weight savings that you can get in the actual rocket structure is going to help you a lot. So I imagine that's probably why they're heading that direction.
Definitely. So after your 25-year career at Boeing, we see now that you've moved on as a technical fellow. It seems in like a similar capacity with Solvay. Could you talk a little bit more about that?
Yeah, it's interesting. I get to see the world from the other side now. So whereas Solvay, I was the customer of Solvay. Now, Boeing and everybody else is now my customer. So I get to see a much bigger breadth of customers. So interactions with Lockheed and Northrop and Airbus and everybody else, which is great. It's as an aviation geek, I love that kind of stuff. But it's also I have to learn Solvay's portfolio. I know it fairly well, but being able to understand what everything that Solvay has to offer and how best it can help the customers is really what I'm about right now. It is interesting that since I have 26 years experience of in the aerospace world and getting stuff certified, I can help our customers approach stuff in a much more practical sense. A lot of my colleagues at Solvay are great in materials, but don't necessarily have the practical experience of building structure, getting structure certified, things like that. And so that's one of the things that I can help bring to the table.
I want to rewind a little bit. 26 years is like a long time to stay at one company. So I'm wondering sort of what you loved about Boeing and why you chose to stay that long.
Yeah, that's a good question. One of the things about Boeing, and it's probably true about any of the large aerospace companies, is it's really more of a conglomerate of 7 or 8 different companies. And so one of the things that I really liked about Boeing was that I had a lot of different opportunities within the company. I didn't really have to leave the company in order to get those opportunities. So I started out in Phantom Works, doing research and development, moved to the defense side of things and supported the F-18, moved to back into Phantom Works and did some other projects, moved into commercial airplanes and helped with the 787, lived in Italy for about 6 months, helping Alenia out. Nice. Moved back into what was now called Boeing Research and Technology, doing more R&D, and got to play in lots of different areas, rotorcraft, spacecraft, commercial airplanes, defense airplanes, unmanned, manned, Horizon X I helped with. So because of the breadth of Boeing and all the many different opportunities that it offered, it just really didn't seem to make much sense to go anywhere else. I enjoyed my time in St. Louis. My wife was from there and her family was there. So she wasn't really too crazy about moving anywhere. So that was another aspect, but I was
Italy.
Well, she went to Italy. She went to Italy, but she was not too happy about it, actually. It was a very tough assignment, actually. It was a part of Italy that was very rural. Very few people spoke English. We spoke very little Italian, and I was working 14 to 16 hours a day, wow. 6 and 7 days a week. So she basically never saw me. She had 2 little kids, and she was kind of there by herself. So not a good assignment for her. She was happy to get back to St. Louis.
Wow.
Yeah, not the picturesque Italy that you think of.
No, definitely not. I mean, we enjoyed our time there at times, when we got opportunities to. It just that 787 program was so crazy, I just wasn't there that much. And I would go to work in the morning, come back in the evening, and I could have been anywhere in the world. I mean, it was dark. I could have, and a factory is a factory. It didn't seem like I was in Italy, other than the fact you would pass tractors on the highway. That was something that was a little different.
So
go ahead.
Go ahead. Oh no, I was just gonna ask, with all this career progression and working so hard at Boeing, what was that one thing that just kept you motivated? Because obviously you had a family and kids that loved and cared about at home, but also your work that seemed to be taking a lot of your time. What kind of kept you motivated just to keep on pushing and stay in that career for so long?
Yeah, it's a good question. Sometimes I ask myself the same thing. You know, the work-life balance is really tough to get. I'm not sure that I've ever gotten it, and maybe I never will. There's been times in my life, the Italy thing was definitely too much on the work side. Getting that right and making sure that you take care of all your needs is tough. The thing that probably kept me going the most was the fact that every day when I go into work, and it's still even kind of true with Solvay, but definitely with Boeing, every day is different. And I wouldn't say never, rarely did I have a day that went according to how I thought it was going to go. Like I would go in the morning and say, this is my plan. This is what I'm going to do. And then, by 9 o'clock, I'm completely off on a different thing. So, you just never knew. There were so many different challenges and so many things that would arise that needed attention very quickly, that you had to kind of prioritize on the fly. And very rarely did I ever work an entire day that went exactly how I thought it was going to go in the morning. And it's kind of fun. Some people don't like that. Some people like to have a structured, and they know exactly what they're going to do. And they don't like changes, and they don't like, but I kind of enjoy the challenge of it. And the fact that things would come up on the fly and I would have to jump in the middle of a fire. So.
Wow.
That's interesting because I feel like your time at the Air Force was probably super structured.
Yeah,
and,
same.
Defined. And then you just described sort of organized chaos at Boeing.
Yeah. Organized chaos. That's a great way to describe it. Exactly. Yep.
So sort of back to the Air Force, what do you think about that? Your time there, like, taught you the discipline? Was it the structure and like the scheduling?
Well, to be honest, I think probably probably 90% of the benefit that I got out of it was the first 6 or 8 weeks, the basic training. So that's extremely structured. You basically can't do anything at any time without, them knowing, and actually they've got it all mapped out for you anyway. You don't get to decide anything while you're there. You're told exactly where to be, when to be, and what to do. But what it did do was teach me a lot about self-discipline, and it also taught me about limits that we set on ourselves. So, and the Air Force basic training is certainly not nearly as physical as Army or the Marines. But there was still enough there to push me to realize that a lot of the times when I said I didn't, or when I thought I couldn't do something, it really was just me thinking that and wasn't really true. So I would say the basic training, the first 6 to 8 weeks, was probably 90% of the benefit that I got personally from the Air Force.
And then what is a technical fellow?
What is a technical fellow? That's a good question.
That was my first interaction with that job title, so I was curious.
Yes, a fellow is not, it's not something that is probably in our common language, So it is somebody who is recognized by an organization or a company as being an expert in their field. And Boeing has a fellowship program that I think a lot of companies have now adopted different fellowship programs. Solvay has a fellowship program of different levels of fellowship. So I started out as an associate technical fellow, ATF, and in that, Boeing's description of what an ATF is would be that you are considered an expert in your field at your site. So like St. Louis would have considered me an expert in composites. Okay. For technical fellow, you're considered, if you're considered an expert by the company. So across Boeing, they would recognize me as an expert in composites as a technical fellow. And then they have senior technical fellow, which is across industry. So if industry considers you to be an expert, for instance, for me as a composites material person, then I could have achieved senior technical fellow. They've actually added some additional levels since then. But those were basically the three levels, and kind of what they mean. So an associate technical fellow, expert in your field at a site, technical fellow, expert in your field across the company, senior tech fellow across industry.
So you're working towards a senior technical fellow right now?
Yes, that is one of my goals for Solvay. It's a little bit murkier to me because I'm just now, I mean, I started with Solvay in November, so I'm still trying to figure out exactly what the process is and what the requirements are, what the qualifications are to become a senior tech fellow for Solvay. But that's very much something that I would like to do.
So what does your day-to-day work life look like right now? Is it still a lot of engineering or is it more management? What does that look like?
It's mostly engineering, which I like. I'm not. I never really wanted to be a manager. I enjoy working with people, but what I really enjoy doing is troubleshooting and fixing problems. So and that's kind of what I'm doing right now with Solvay is if there's issues at suppliers, if they're having problems building parts, they'll pull me in to get my opinion on what's going on. That's one aspect of it, which I really enjoy. The other aspect that is a big part of what I do is what is the future going to look like and what should we be developing? What kinds of resins, what kind of fibers, what sorts of needs does the market going to have in 5 to 10 years? And how can Solvay be positioned to meet those needs?
Such a valuable role to have. And I don't think we've talked about it yet, but we noticed the laminate life, and then we have the rule of composite. It looks like the 10 commandments for composites. Could you talk a little bit more about what you do at laminatelife.com and your motivation behind that?
Yeah, that's so what that is that's kind of the fine arts English part of me coming out, right? So and also I will tell you this, and those who know me will attest to this, that I have kind of a weakness for dad jokes. So I'm the composite truisms kind of started it all off, which is the ply table that you see behind me. And I put that out on LinkedIn, and I was surprised by what reactions there were to it. It was very well received. And I think what I tried to do is blend humor and truth. and for the people who have experienced composites, they can read through that stuff and, their heads are nodding because they're like, yeah, I lived through that. I know exactly what that means. But it's also a good way to share my experiences. And that's kind of what Laminate Life is about helping each other. And so, when there's lessons that I've learned that I can maybe, help someone else to learn, I would like to do that. It's a good thing to learn from your own mistakes. It's a great thing to learn from someone else's. And right. So, if I can throw some stuff out there that people, that I've experienced, that I've, failed at and learned from, and then people can maybe learn from it without having to fail themselves, that's a great thing.
So is this, I've noticed this theme throughout your career of wanting to give back, wanting to help, other engineers and just people that you care about. Is that one of those motivation to give back a part of the reason why you became I see that you're a SAMP fellow. I don't know if I'm pronouncing it right. I don't know if it's SAMP, but Society for the Advancement of Material and Process Engineering, and as well as a fellow of the Academy of Sciences at St. Louis.
Right. Yeah, so that's SAMPE. SAMPE is a worldwide organization of materials and process engineers, primarily composite focused. Used to be very heavily aerospace focused and is still pretty aerospace, but opening up to more and more fields now, I think. But yes, I would say that probably one of the biggest things of my career that I enjoy doing is teaching and mentoring. So I really enjoy being able to share what I've learned with other people and to help them advance their careers as well. So it's not something that I typically do as kind of a formal thing, but I'm pretty informal about stuff. And so that's why I welcome people, and I get people almost daily IMing me in LinkedIn with questions about stuff. And it can be about anything. It can be a technical question. It can be a question about a job or a career, whatever. And if there's, things that people want to bounce off me, I'm happy to share. I've had a lot of people in my career help me along the way. I'm not where I am because of who I am. I'm here because there's been so many other people who have taken an interest in my career and helped me along the way. And so I want to pay some of that back.
Amazing.
Well, I think that's how we found you. Is Uriel messaged you, and then
Yeah.
So we appreciate that. It's really cool.
Yeah, no problem at all. Happy to be here. Happy to help.
We love having you as a guest. Definitely a very interesting conversation thus far. We were talking, you mentioned how in your current role with Solvay, you're a little bit more focused on the future and developing the position of Solvay as a company for the future. And since I've been following Solvay on LinkedIn as well as yourself, and I see that unmanned aero mobility is part of that future. And I don't know how far in depth you can go, but just if you could share, what you understand, what you see of that space and that market, that would be definitely something that we love here at Texas Guadalupe. We're all about more efficient transportation systems and technologies.
Absolutely. Yeah, I think that Solvay recognizes the future potential of urban air mobility, advanced air mobility, Hyperloop, whatever form the future of transportation is going to look like. And my guess is that it's going to be a mix of it all. It's not going to be a winner take all. It's going to be a blend of all these things. One of the things that I see as sort of a common thread is the need for very weight efficient structure, especially for the advanced air mobility folks, just because power density of batteries is not where the fossil fuels are right now. Obviously, there's a lot of battery technology and improvements that have come over the even the past couple of years or so, and they will continue. Nevertheless, I believe that weight of the platforms is going to be critical, and composites can definitely help with that. At the same time, we need to be able to produce structure in a cost-effective manner, and we need to be able to support it in the field. As the owner of a 1978 Grumman Tiger, I can attest to how beat up stuff gets, even when you have a careful owner, And so can you only imagine what air taxis might look like after a few years out in the field? So we need to have structure that's robust, certifiable, repairable, maintainable. It's not just about creating the structure initially. You got to look through the whole life cycle, and actually even beyond the life cycle to, we talk about cradle to grave. Well, beyond the grave, we're talking recycling and how do we keep these platforms out of our landfills and turn them into something, more useful after their life is done as a urban air mobility platform. So I see all of those things kind of playing. I think Solvay is well positioned for the initial round right now. We have material systems that are out there that are already characterized and have full allowables, and are basically just kind of pull them off the shelf and run with them. But I do think that in the future, higher modulus carbon fibers is going to be a player. I think that VBO, vacuum bag only stuff, is going to continue to be important. I think that automated processes to be able to repeatably and quickly and efficiently build structure will also be a major factor as well.
So things like AFP.
Yeah, AFP, stamp forming, ATL. There's lots of different ways. I know that one of the things that people are pursuing is additive manufacturing, 3D printing, and 3D printing of continuous fibers. It's called AFP. That's what we've actually done that for a long time, right? We don't call it additive manufacturing. We don't call it, well, it is additive, but it's not 3D printing. But AFP essentially is, building up kind of layer by layer of a material with continuous fibers. So I think there's going to be more technologies like that coming out. There's going to be more processes, more automation going to be put into this, not only to reduce cost, but to also ensure repeatability, because that's going to be a big one. You're going to have to build not just maybe 10 or even 100 a year, but maybe 1,000 or 10,000 a year. And we're getting closer and closer to an automotive kind of approach in aerospace. And I can see kind of aerospace and automotive almost blending together. Automotive now picking up a lot of the carbon composites and things like that with BMW, and aerospace borrowing from automotive to get to the higher rates.
So in terms of lifespan, do composites have a similar lifespan to like a steel in terms of what you're saying? Like,
I'm sorry, you said a lifespan similar to what?
Like a steel or aluminum?
Oh, steel. Yeah, well, I would say that their lifespan, if they're properly designed and kept below the limit load for any fatigue issues, they're essentially infinite. So there is no lifespan other than some kind of damage that's been caused to it, external impact or something like that. But as far as a fatigue or corrosion limiting, there's none of that with the composites.
So you were talking about, and I've noticed that Solvay is really big on sustainability and just being aware and conscious of the impact that their technology has on the environment. As a private pilot, I'm sure you're very aware of that too yourself, having to be aware of birds and just the weather in general. So I guess from that perspective of a private pilot, what other challenges besides manufacturing do you see in the electronic vertical takeoff and launch vehicles such as air taxis that are being developed right now?
Yeah, so I think there's quite a few challenges that are out there that are going to have to be met. I think certification of platforms and integration of both manned and autonomous vehicles into the national and international airspace is going to be very interesting. It'll be interesting to see how they do that. As a private pilot myself, I'm very concerned about congestion of airspaces and I love to meet pilots, but let's not do it in the middle of the air. Okay. I mean, that's
crash into somebody's drone.
So, some of that is there. I think that, looking at the whole picture and not just, can we build these platforms, but what are we going to do with these platforms? How are we going to support them? How are we going to maintain them? And what are we going to do with them when we're done with them? Is important things that and some challenges I think that we really need to look at. And to be honest, I think we probably are going to get there with the composites. I think the batteries and the other systems may be a bigger challenge in a recycling standpoint. I'm no battery expert, but it looks to me as if that might be a bigger challenge than the composites itself. But all of that needs to be taken into consideration.
Mm-hmm. And maybe that's something that Tesla could. You were talking about this cross collaboration between aerospace and car manufacturers. That's something that, as far as battery technology is, that Tesla's working on.
Exactly. Yep.
So the future does look bright.
Oh yeah, this is. I got to say, this is a tremendously exciting time to be around materials and aerospace aviation. There's just all kinds of new things that are out there. It's in some ways it kind of reminds me of sort of the early 1990s and some of the internet boom stuff, where you had a lot of software companies out there developing stuff that nobody had ever really heard of. And this company that started selling books online is now one of the major, Amazon is now, huge, right? And sells everything. Google, I used that search engine before anybody even knew what it was. And now it's, Alphabet is all over the place, right? So who knows where this is going to go? But it is an exciting time. It is interesting, though, that one of the challenges I think that they're going to run into, all these different companies, and I think there's probably over 150 of them that are doing urban air mobility. is the market cannot sustain that number of companies. I don't believe. Some of them are just going to naturally drop out. And the thing is, when you're building flying platforms, it's not just whatever you can devise on a computer that works. You have to deal with physics, and real world stuff. So it's I think in some ways it's like I think SpaceX has kind of experienced some of this. It's not easy. This job is not easy. I think they can do it. I think they'll get there. But I think there's going to be a lot more challenges than maybe a lot of people realize.
Oh, for sure. I'm wondering, outside of Solvay, is there like a certain project or vehicle using composites that you're most excited about?
Ooh, that's a good question. Wow. I don't know that I have any one particular project. I see a lot of companies looking into composites that maybe wouldn't have otherwise, because of the VBO and because of the fact that we can get out of the autoclave. I think is really opened it up to a lot of people. And I think that people who are looking at new processes and new materials in ways that we haven't really before thought of traditionally of applying them. Scaled composites is one of the great examples of being, kind of out of the box thinkers in the ways of composites. And I think that a lot of the new urban air mobility or advanced air mobility folks are coming along and looking at that and saying, yeah, we can do that, or we can even go one better. And so I'm not sure that I necessarily have one particular project that I have my eye on. I'm just kind of seeing the industry as a whole really starting to innovate in some things, and it's pretty exciting.
Yeah, that's cool. And being in it for 27, 26 years, you've probably seen it grow a lot.
Yeah, for sure. It's amazing. And yet it is also interesting that some of the challenges that we overcame, 20, 30 years ago are still challenges that have to be overcome today. In some ways we still relearn the same lessons. Wow. That's one of the reasons why I like to do the Laminate Life, is because I want to kind of get those lessons out there for people that maybe they don't have to relearn them, that they can just, press on from there.
So in your career, looking back on it now, what would be like the one biggest piece of advice you would give to 22-year-old Gary?
Wow.
If you could, travel back in time and talk to yourself, I guess.
Yeah, I think probably the thing that I probably would want to work on most, and probably didn't do very well in my early career, was listen. So, I think that there's really two steps to innovation. I hate to break it down so simplistically because it's much more complicated than that. But if you want to innovate on something, I don't know if you guys ever saw, there was I don't know, maybe 15, 20 years ago, an animated CGI movie called Robots. And it's got in there a guy who's a great inventor, and his motto is see a need, fill a need. And I think most people want to jump right to the fill a need, because that's the cool part. That's the hands-on, that's the innovation part of it, right? But you really need to see that need first. You have to observe. And we've been designed with two eyes and two ears and only one mouth. So we should be talking like 20% and observing 80% of the time. And I think we kind of get that upside down a lot. And so innovation, I think, starts with kind of an act of humility, that you have to. There you go.
There it is.
That's exactly what I'm talking about, right? Yes, the solution to every technical challenge starts with two essential pieces of equipment, right? So you got these, and you also got your eyes. So you need to observe. You need to listen and observe. And when you do that, you are essentially humbling yourself. You're saying, I don't know everything. I don't know what the need is. I'm not sure what the problem is to solve. You first of all have to identify what the problem is before you can go solve it, right? So I think it's what I would probably advise myself, my 22-year-old, well, actually 29 when I started my career at McDonnell Douglas, but I would say, listen and watch. And it's not just the things that are happening at work, but do it in the rest of your life as well. It's surprising how many times I've had things that I'm just walking, outside, or I'm working in the house or whatever, and something just clicks that what I'm doing or what I'm thinking about or what I'm looking at could have an applicability to something at work. So being able to kind of observe things that are around you and absorb that, and then be able to make the connections to a problem is really the key, and something that I've kind of learned over years. I'm definitely not perfect in it, but something that I wish I had started a little bit earlier.
I was just gonna say there's a lot of funny dad joke T-shirts on there too, so definitely check it out.
Yeah, if you have a sick sense of humor, you might enjoy it.
Well, I think we've taken up a good amount of your time. Probably eager to get back. I want to thank you so much for coming on and for being so open on LinkedIn and responding to people. And keep posting those pictures that make me jealous.
Of course.
Thank you so much for your time today, Gary.
Appreciate it. I appreciate the invitation and the opportunity to talk with you guys. It's been great. I wish you guys all the best, and we'll continue to follow the Guadalupe and all the work you guys are doing.